Let's analyze this example. Right here we get a leveler ABC, similar to the one we have used before, loaded as shown. The difference of this diagram for the one in the first problem and the one in the third problem, I think it was, is that the lever is a little bit inclined. Actually, it's inclined by 30 degrees here. The problem also said what must be the value of the distance r, this distance, so that the force couple creates a moment of 1.5 newtons meters. It doesn't say the direction of the moment. However, if we look at the couples and how they are arranged, we will see that the moment must go negative clockwise. Why? The force in the left is going up, the force in the right is going down. That means this one will push this way, this one will push this way, creating this rotation. So we know that the moment is going to be negative. So how do we work when we have an inclined plane and forces vertically arranged like this? These two are going to be a couple, no doubt about that. And they are parallel, no doubt about that. We got two ways to work. We can either rotate these and see how they look like, or just as it is, calculate what are going to be the components of these forces that are actually perpendicular to this distance. So why is that important? If we set the perpendicular component of the forces to the lever, we will not have to make any further calculations, and this one right here is going to be the distance that's shown in the equation, distance times force. If we know this distance, we can get what's going to be the value of r. So the easy way to go is to find out the angle between my force of 10 newtons about not the horizontal, but about the lever. This angle can be called as alpha. How can we find out what's the value of alpha, which is going to be the one that we use to decompose? Well, if we extend the line of the lever, we will see that this full angle is going to be 180. From this full angle where we have two elements. First element is going to be given by the 30 degrees in here. That means this displacement is going to be 30 degrees. What is going to be the other known section? This one right here. If we know that the force is fully vertical and we know that this angle right here is referred to the horizontal, I will know that this one right here is going to be actually 90 degrees. So this section right here can be calculated as alpha equals to 180 minus 90 minus 30. It would be exactly the same if I work from here. If we work from here, we know that here, side to side, we will have 180 degrees. I know that this one right here is going to be a 30 degrees. There must be an angle of 30 degrees in here, and that this one right here is going to be 90. So once again, I can calculate the alpha based on the 180 minus 90 minus 30 degrees. So the value of that angle is going to be 180 minus 90. That's going to be 90 minus 30. That make alpha actually to be 60 degrees. Now, why is that important? Well, if we know this angle right here, which is 60. That means I can decompose this vector in one component that goes this way and one component that goes this way. This one right here is actually the force I'm looking for, the force perpendicular to the lever. Works the same for this one. We know this angle is going to be 60 degrees. If that's 60, I can calculate what's the magnitude of the component that goes this way, which is going to be the opposite side of the 60 degrees, and the component that goes this way. Now, do I need to make further calculations? Not that much. Why? What happened with the other section of the force? If I know the forces that are perpendicular are the ones that are going to create the moment, what about this force? What about this force? These forces are going to be force parallel. That's not an 11, that's parallel. Force parallel to the lever. If these two forces were 10 newtons each, if they got the same inclination angle, that means F perpendicular in here and F perpendicular in here are going to be the same. And that's going to happen with F parallel and F parallel. This F parallel goes to the left, this F parallel goes to the right. That means that they are going to cancel to each other. So we can represent the system as these two forces. And to make no confusions in here, the forces are not going to play like kind of away from the application force. Actually, the forces are going to look like this. In this place, we're going to have force perpendicular. In this place, we're going to have force perpendicular. Force parallel is going to go this way. Force parallel is going to go this way. How do we calculate them? Well, if we already know alpha is going to be 60 degrees, we go and find force perpendicular equals to force times sine of alpha. Force perpendicular is going to be 10 newtons times sine of 60 degrees. That's going to deliver 8.66 newtons. 8.66 newtons. That's the value of my perpendicular force. If that's the value of the perpendicular force, and I already know what's going to be the moment they have to create this distance d, can be easily calculated based on this equation. So I already know mc. I already know the force. We solve for the distance. Distance, it's going to be equal to mc moment over the force perpendicular. That means we will have 1.5 newtons meters over 8.66 newtons. That's going to deliver 1.5 over 8.66, 1 point, sorry, 0.1732 meters. That's gotta be the distance that goes from here to here. If I know the total length of the lever, that total length is going to be 10 plus 20. That means 30 centimeters equals to 10 plus 20, or it will be equals to 17.32, which is this one in centimeters, plus this section, which is going to be R. From here, we solve for R. We'll have that it's going to be 30 centimeters minus 17.32 centimeters. That means the distance from here to here, where my force needs to be applied so that I obtain this moment, it's going to be 30 minus 17.32 centimeters. That's going to deliver a total of 12.68 centimeters. We are ready.